we will solve this today's LeetCode problem. This is word search, right? So let's see what it is. This is given an m cross n grid of characters, bold and a string word, and we need to return true if word exists in the grid, right? And the word can be constructed from letters of sequentially adjacent cells. It means uh, okay, we can also only move in horizontal or vertical direction, not diagonally, and the same letter cell may not be used more than once. It means that this if we comes to a, then we don't count again this a, right? We don't move to this cell again this a and they count make this take this a value, right? So this means that. So here this is given a b c c e d. So as you can see in yellow highlighted that this word is present in this matrix. So and so yeah, so how this approach, how we can think of this approach, right? So if you think, so we need to simply go to this matrix and search for this first character. We will go to this matrix and we will go to this first character. The first thought which comes to mind that we will simply go to every character and search in all the directions and match with the every characters with this word, and if that word matches, we will again iterate in all the four directions of that character, and again we will see that if whether the next character of this word is matches with any of the four cells, then we will continue to move in that direction, right? So the basic approach was that is that. So what we can use recursion, right? That if you say that that is the DFS approach here, depth first search, right? So we can use here DFS. So and depth first search here, right? So what we do, we will simply, I have already written this matrix here. So what we do, we will move to this first index. We will see whether this matches with my current first index or not. So let's take this here word here, right? So int denotes the length. Int denotes the length of. Int denotes the index of word, right? Word, and ij denotes row index of matrix, row index of board, and j denotes column index of board, right? So we have started from I is equals to 0 and j is equals to 0 and x is j and 0. We will see first that whether this matches with this character or not. If this matches, I will move to its in four direction, right? So if you see, we can move only here and here, right? At I is equals to 1, j is equals to 1, and I is equals to 1, j is equals to 0. We can't move in, because if we move in other two direction, it is out of bound. We can move only in this and this, right? So if you see, so if you move to this p, so there is also match with p, so we can continue in this direction. But if you see in s direction, this is not matched with this b direction, so we will not continue in this direction. So till now we have got ab, right? Till now we have got ab. Now again I will move for bth in four direction, so we can move in c or either in f. So if you see, this c value is again occurring here, not here, so we will not continue in this direction, we will continue in c direction. Now again I will move, I will iterate in, I will see all the four direction of c. So here I will, if you see, this b is already visited, so we don't visit this b again, and because it is already written that the same letter cell cannot be used more than once. So this b, we will not iterate in b. We can move in right direction or in down direction. So if you see that the current index is c, so we can move in c, we can move in below direction, not right direction, because it doesn't match with my current character index. So we will move to this right part, right? So till now here this ABC and till this C, right? Now again I will see the see the four direction cells according to this C. So we can move either in right, either in either above, either left, or either below, but we can't move above, right, because it is already visited. We let's see, this current index character is E, so we can't move in right direction. We also can't move in left direction, right? We can only move in down direction, which is E. So we will move to this E. Now we again see in four directions. We can't move to above because it is already visited. We can move in right, but it is E, not D. We can move in left direction because D. So we have completed my word search in this, and got my word till here. So we will return simply 1 and the answer should be true here, right? So what we are doing, we are just going to this word cells and matching with the word index, that whether this character is same or not. If it is same, we are searching in another four cells for next character, otherwise we are returning 0, right? So here we the depth first search uh, is the most optimal approach here for seeing this, and we also need to uh, maintain a visited for that, so that we don't move in visited cells every time, right? Just in case of C, we don't move this B again, so we need to also maintain a visited. Let's see how we will do this. So first, let's take, okay, so if I see also the constraints here, so this is only end to end, which is 6, right? And this word length is 12 15 only, so we can use DFS approach here, right? So let's take as a board, let's take this as a n cross m, which is word board dot size. This should be board dot size, and this is board 0 dot size. So this is for row and this is for column. Now again I need to see the word length, word dot size. Let's now I will first match the character of first word index, right? So for that I need to iterate in all the matrix, and whenever I get, so suppose my word this board ij is equals to this my current the first character of my word, right? If this is correct, then what will we do? We will simply uh, we will simply search in my I will make a search in my DFS and pass this ij, and also I need to pass my word here, and also need to pass my board here, right? So I also need to pass the zeroth value to for counting purpose. And if suppose I have already implemented this and I have got 1, so I will return simply 1. And after, if we don't get value return 1, it means we haven't got my word in my matrix in my board, so I will return 0. Now let's solve this, let's implement this solve function. So let's what we can do, we need to return the true or false here. So here this is row, this is column, this is the index of word for word, and this is string word, and this is vector cat board. This is a board matrix, right? So now what will we check? We need to see whether this word character, the current word character, is equals to my board ij or not, right? So what we will see that if, so what will be the base condition first? So base condition will be what is the base condition here? So I'm just okay, I need to also for making iteration I need to make this uh, so that I can move in 4 directions. So I need to define it first, that how I will move in the 4 directions. So here this is 0 comma 1, yeah, this should be the 4 direction. So I'm just iterating again and again in its 4 direction, incrementing or decrementing again and again. So I need to check if my I less than 0, I don't go out of bound, right? So I need to check if I'm going out of bound or not. Just uh, yeah, so I need to check whether I am going out of bound or not, right? So this is for out of bound condition. If I am going out of bound, I will return simply 0, right? Now if the current index, if my board ing is not equals to the word index, I will also return 0, but because there is no point in moving further in that direction, right? So I will also return 0 here. Now what will the again conditions? So if this index is, so I need to check this in before here. So if my index is greater than this size value, so in that condition I need to return 1. Why? Because if this is true, it means I got my word length, which is I got my word characters, all the characters in board. That's why this index size is incrementing here, right? So what I need to do, I will simply iterate in all the 4 directions for here, right? And I will simply move in, make a separate directions. This is I, this is J, and this is J, right? So this is X and Y. If this board ij is word index is equals to my word index, I also need to mm, uh, change this value to something which is not in this character. So let's make this something like this type, right? Something this or any characters you want other than alphabets, right? So why I'm doing this, so that we don't visit the same cell again and again. So I mark this as a board ij, and for this I also need to store my board ij so that I can backtrack this. So I can backtrack this whenever my this solve function ends. So that I can backtrack this again, because I need it's possible that I need to visit that cell again, because we need to see if for every cell, suppose this is a here. So again I comes to this a, so I may visit all the cells again. So I need to maintain this board ij and backtrack this, and maintain this ij to c, right? Now again I need to see this solve function. So I will move to this solve function, and also I need to increment my indices, and I need to pass this word and board, right? So if this solve function gives me true, right, anyhow I am iterating in all the directions, and if this solve function is giving me true from any of the direction, I will return simply 1, right? Otherwise I will simply return 0. Understood? If the solve function gives me anyhow in any direction 1, return whole value 1, does it mean that it is it hits this condition? If it returns 1, I will simply return 1. Otherwise I will return 0, right? Now I think I have, so let's see this condition here. If I index is less than equals to j, suppose there are characters a only, and I move to indices 0. If this a matches with me, then I move to indices 1, which is now equals to 1, and the size is also equal 1. So this will return me 1, which is correct. Yeah, this should condition is correct. And this also is correct, this is correct, this is the board ij. I have written this here and I maintain the backtracking process, and I'm moving whenever I'm getting this one, otherwise I will return 0. Yeah, I think this should work. Let's run this. Yeah, we passed the test cases. Let's submit it. Yeah, we passed all the test cases. Yeah. So it's basically a DFS problem. So what will the time complexity here? So that, let's analyze time complexity, right? So the time complexity will be, we are moving for every we are moving in all the cells of matrix, so that will be O of m into n due to this. And for every cells we got a matching value. I'm iterating in solve. I am applying DFS for every cell. So, and for every cell there can be the 4 direction possible, right? So there can be 4 direction possible. So that will be 4. This 4, and this should be the power L, right? This should be the power L. L is the length of a word, or you can take anything, this side or something. What is the L here? L is the length of word. So whenever we get any matching word, I move into that direction. So the length of the word will be the possible length, and I need to move in all the 4 direction. That will be the 4 to the power L. And this n into m is the matrix cells, number of matrix cells. For every matrix cells I need to maintain this. So the time complexity will